Welcome back to the YouTube channel. I'm Rishi, and before we start today's video, let me give a bit of an announcement. I've been posting for the past few months slash weeks on and off, but from now on, from today onwards, I will be posting at least one video per day. So the videos will get a bit shorter and much more viewer friendly so that you don't have to spend a long time to watch the videos. So with that in mind, I'm going to be posting two videos on one topic covering different aspects of it so that it's much easier to be consumed. So today we are going to take a look at Form 2 Chapter 2 Algebraic expression, and we're going to mainly focus on expansion and factorization. So without any further ado, let's get right into it. Algebra, one of the most feared subject by all. Not by all, but by most. So whenever I encounter algebra, whenever I'm trying to understand a concept in regards to algebra, the first thing that I do is try to use normal numbers first. Try to use the numbers that you're used to understand the concept, to make sense of the concept, before we start using unknowns. X and Y's are cool, but if you don't understand the concept, they tend to get a bit confusing after a while. So when you are studying algebra, it's very, very, very important. I can't stress how important it is, but it is that important to understand and internalize the concept of how the whole mechanism works before you start applying it on questions. So we have two parts to this. In this part, I will be explaining about expansion and factorization, how to use them. And in the next video, in the next part, we will be discussing on how to apply the concepts that we learned in this video to solve actual questions that may come up for exams. So for expansion, as I said, before we get into using unknowns, it's important to understand the concepts. Expansion works something like this. There will be a number outside, for example, 6, and there will be a kind of an expression or a term or a number inside a bracket. So in this instance, let's put 8 plus 6. So if we were to do this normally, we would just write down this equals to 6. We will add it together inside. 8 plus 6, we get 14. Then we'll have 6 times 14, which if you multiply, you can use a calculator, you will be getting 84. That's how we are used to doing calculations. But in case of an unknown, for example, if instead of this number we have 6, 8x plus 6. So what changed here? What changed here is that here we have an unknown attached to the number 8, which prevents us from just adding them together inside. But this is not a simplified form as there is still a bracket. So what you should do here is something called expand. So to show you the expansion, I will not use this. I will take off the x. So we just use the same exact expression that we have from earlier, 6, 8 plus 6. So what you should do here is use something that is known as the butterfly method. Something that is known as the butterfly method. And if you're wondering what that is, this is my best attempt of trying to draw a butterfly. It may not look like a butterfly, but you understand the gist of it. So the butterfly method is when you connect the number outside the bracket to the numbers inside one by one. 1 and 2. This is commonly known in Malaysia as the butterfly method among the teachers. But you can call it whatever you want. You can call it the rainbow method, the butterfly method. and various others. These terms might be repeated for some other concepts, but just understand with what you understand best. Butterfly, rainbow, both are the same thing. So 6, 8, and 6, 6. All right. So what this line symbolizes is that it's a multiplication relation. Multiply, multiply. So what you do here is you take the number 6 and multiply it with 8. So 6 times 8, you get 48. And 6 times 6, 6 times positive 6, remember there's plus attached to the 6. 6 times positive 6, you get 36. So 48 plus 36, you end up with the number 84. As you see, both of this, although done in different manners, still get you the same exact answer of 84. So with that, we know that it's possible to to add inside the bracket and multiply it with multiply with the number outside, like this. It's also correct, and it's also not wrong to do it in this manner where we expand it. This is the term. This is what we call expand. Expand it by multiplying the number inside with the number outside one by one, then adding them at the end. So since now we know that this particular method is correct, we can use it to solve the question that we had earlier. Remember? The one where we said 6 times 8x plus 6. So in this instance, we can't add 8x with 6 because there is an unknown attached to it and they both don't belong to the same family, or should I say the same category. Therefore, we will have to expand it. The same concept applies. You're going to multiply the outside number with the inside number one by one, 1 and 2. So here, what you can do is 6 times 8x. So 6 times 8, we get 48. And there's nothing to times x with, so we just leave it as x. So 48x plus 6 times 6, positive 6. 6 times positive 6, you will get 36. And since there's an x attached to 48, we can leave it just like this. This is the most simplified form for this particular expression. That's it. Expansion in a nutshell. So just remember, expansion is when you can't add up the numbers inside the bracket, which forces you, there's no other way, which forces you to expand it with the number outside the bracket so that you get a simplified version of it. Remember, you are not solving it. Solving means you're finding the value of x. Now you are just simplifying it. You are not solving it, you are simplifying the expression. And this is algebraic expansion. If you can't understand the concept, I would recommend you to watch this part of the video one more time so that you get a better understanding of it. And then after expansion, let's move on to factorization. Don't worry, factorization is not as difficult as people say it is. I agree that it's a bit more difficult compared to expansion, but it is not actually that bad. Just think of expansion as times and factorization as its counterpart, as its opposite, which is divide. If you can do expansion, most definitely you can do factorization. So for factorization, you are going in reverse. So if expansion is times, then factorization is divide. Let me demonstrate it to you. For instance, we have an expression 48x plus 36. So for those who are keen observers, you might have noticed that I'm using the exact same example from the top. But let me explain to you why I use it. So 48x plus 36. All right. I'll explain it to you in a bit. So 48x plus 3 36. Imagine you get this for your exam. So the first thing they're asking you to do is factorize it. So to factorize is it's important for you to understand the concept of HCF. That should ring a bell for you. HCF. This is something you learned in Form 1. HCF stands for highest common factor, which means the highest number that exists in both the timetable of 48 and 36, or the highest number that can divide both 48 and 36 at the same time. That is highest common factor. So for instance, if you have we have 6 and 9. So the highest common factor for both of these numbers will be 3. Because if you take a look at the timetable of 6 and 9, the highest number that could divide both 6 and 9 will be 3. That's the definition of highest common factor. So in the instance of 48 and 36, if the numbers are big, we don't have to crack our brains and try to will the answer into existence. Instead, we can just do the repeated division method to find out our answer. So 48 and 36. So here 40 and 36 are both divisible by the number, let's go small, 2. So we'll have 24 and 18. Then let's go another time, 2. So we'll have 12 and 9. And let's go 12 and 9 can be divided by 3. You'll have 4 and 3. And that's about it. We have 2 times 2 times 3. So we will just have to multiply this. And what you will get here is 12. So this is the number that we're going to factorize out of these two, since this is the highest common factor. So here you will have 12 outside. So inside, we will have 12 times what? We get this 48. 12 times 4 right here. 12 times 4 gives you 48. And 12 times 3 gives you 36. And for the x, we are not going to disturb it because there is only x to one of the terms. If there were to be another x on this side, we will factorize the numbers first, then we'll factorize the alphabets. No worries, I'll show you another example so that you can understand it better. But that's the gist of factorization. You do highest common factor, and then you divide the number. You get the number you get the highest number that divides both of those numbers, so that you can put it outside the bracket. So if you take a look at expansion and factorization, you will notice that expansion is the process of getting rid of the bracket, while factorization is the process of creating a bracket or set of brackets. I'm not picky with grammars. So expansion is the process of getting rid of the brackets, and factorization is the process of making the brackets appear in the first place. So they are both polar opposites. So I'll give you one more example with factorization, including unknowns, so that you can understand how it actually works. So for example, let's have 12y squared minus 4xy. So here we are presented with an expression. So the same concept applies. Firstly, for the numbers 12 and 4. So if we do HCF, let's speed out the process. 4 can be divided by 4. You'll have 3 and 1, and that's it. We have hit the number. So it's 4. 4 will be outside, and inside we will have 3 from here. Then we'll have 1 on this side. So let's just put 1 first. and we'll have 3 minus 1. So now let's take a look at this. Let's take a look at the unknowns. So once we're done with numbers, we can cross the numbers off. Next we have y squared. So y squared, the term y appears on both terms, 12y squared and 4xy. So we have two y's here, we have two y's here, and we have one y here. If we would take out the common factor from both of it, it's wise to take one y out because this term only has one y. So if when you take out one y from both, we will have one y remaining, and then that will be no y's here. So we get 3y minus 1, and then as you can notice here, we will have x. This x only appears in one of the terms. 12y squared doesn't have an x, and 4xy has an x. So if there is no commonality between both of the terms in terms of x, we can just leave x to be alone. Don't have to disturb it at all. Coefficients or numbers or alphabets that are not related to any kind of division or factors can be left alone. There's no need to disturb them. So we will get 4y. Remember we take out the y earlier? It's important to write it at the front. So we'll have 4y times 4y in bracket 3y minus 1x. So for algebra, there's no need for you to write 1 here. You can take out the 1, and you have 3y minus x. You can always verify your answer by doing it the opposite manner. To make sure that you factorize it properly, if you try to expand this expression, you should get back the initial answer back, because initial question by not answer. This is because, as I told you earlier, expansion and factorization are opposites, just like times and divide. 4y times 3y, you will get 12y squared. And 4y times x, you will get 4 minus 4xy. As you can see, this corresponds directly to the question given. And that's about it. And one little fun fact. Even though y is here, when I times it with x, I wrote it as 4xy. You may ask, is there any order? There's no order. It's alright if you write 4yx, there's no problem. It's just that mathematicians prefer to follow the alphabetical order, x, y, z. It's just a thing that mathematicians follow. There is no need for you to follow. You can write 4yx, it's completely fine. It's just that writing it as 4xy following the alphabetical order seems, for the lack of a better word, nicer. And that's all we have for expansion and factorization. It's as simple as that. And in the next video, I will be covering on how to use this knowledge to solve questions regarding expansion and factorization. And also, we will be going in depth on a few special cases that are related to factorization. So stay tuned. This is just the basics. We will have more in the next video. So with that, if you have any questions, feel free to send an email. My email address is in the description box below. So feel free, and see you in the next one. Bye bye.